Okay, solving linear systems graphically. For anybody that was planning on doing NROC, to submit your notes, you don't have to write this stuff down, but this will help you get through Deltamath a little bit quicker, I think. And if you do copy this down, you can submit this as your notes. Just wanted to reiterate that. Solve linear systems graphically, level 1. We'll do a few different levels of this. And holler out if you can't read any of that, but solve the system of equations graphically. And systems of equations, that's basically just multiple equations. The systems that you guys are going to see are just going to be 2 equations. So system of equations, just 2 equations. So if we've got y equals x plus 4, and we've got y equals -3/2 x minus 1. Hopefully you all get to the point where graphing, if you've got y by itself, is relatively easy. But you do want to get y by itself to graph. On the level 1 ones, they'll already have y by themselves. So all you'll need to do is start with the what we call a constant. It doesn't have an x on it. It's just a number. +4, -1. So if we're graphing, I'll do the first one in green. Y equals x plus 4. So the 4 is going to tell us where we cross the y-axis. And there's an invisible number in front of that x. It's a 1. And there's also a number underneath that, 1/1. So you'll want to keep that in mind because that'll come up. 1/1, which basically means the number on top is the rise, the number on bottom is the run. So we've got the 4, and then from there, we're going to rise 1, we're going to run 1. Rise 1, run 1. Whatever's in front of x, that tells us our rise and our run. So we're going to go up 1 and then over 1 and then put a dot. Okay, so I'll do the other one in blue. So where's the first point we're going to put on that one? -1. So dot there. And then we've got our rise here, -3, and then our run 2. So down 3, over 2. You could also go up 3 and then back 2. The minus has to either be on the top or the bottom. I mentioned last time, don't do it for both, but either the top or the bottom. You could go up 3, back 2, down 3, over 2. I'll put a solid dot right there. Okay, and this could be a little tricky to demonstrate, but the solution is going to be the intersection point. That's the solution. Let me see if I had to guess what that was. It'd be negative. Well, I'm not going to guess, but basically when you put this on the computer screen, it should be pretty clear what that point is, you know, where they intersect at. So if you have any trouble when you get into this, and this is still a week down the road, this is notes for next week, really. With module 3, when you get into there, if you have any trouble figuring out what that point is, it probably means that something else is wrong, because it should land on one of those perfect grid intersections, and you can say this is -3, +2, and always remember to put the X first and then the Y. And that's basically how you come up with the solution. So doing the same thing, except we were at level 2 here. Solve linear systems graphically, level 2. Got y equals 3x minus 1. We've got x plus 2y equals 12. Y equals 3x minus 1. X plus 2y equals 12. So the reason this is considered level 2 is because that first one is easier to graph. You've got the -1 that you'll start with, and then you'll go up 3. Rise and run is always whatever's in front of x. So you'll go up 3 and then over how much? Over 1. So up 3 over 1. We've got that invisible 1 underneath. But like I mentioned on the last one, you do want to get y by itself in order to graph these. So this is level 2 because this second equation doesn't have y by itself. So on this one, we're going to get y by itself. Get y by itself. So we'll move the x to the other side. We'll divide by 2. And then we should be able to graph. So x plus 2y equals 12. We're going to move the x over, we subtract it on both sides. So x is gone from the left. You have 2y equals, I'm going to put the x first, -x, and then that's a +12. Still trying to get y by itself, so divide by 2. Divide everything by 2. So we've got y equals negative. There's an invisible 1 in front of x, so I'm going to go ahead and write that. So 1 divided by 2x, and then 12 divided by 2 is just 6. Okay, so now we've got this equation we can graph, and we've got this equation down below that we can graph. So starting with 6, we'll go down 1 over 2. On the other one, we'll start at -1 and we'll go up 3 over 1. So I'll do the top one first. We'll do that in green. -1, put a dot there. And then up 3, 1, 2, 3, and then over 1. Okay, and the other one going up to 6. I'll do this in orange. So 1, 2, 3, 4, 5, 6. Put a dot there. Looking at the 6 there. And then we're gonna go our rise and run. Always whatever's in front of x. Rise and run from that 6. So we're gonna rise -1. So going down and then over 2. Down 1, over 2. That's our second dot. Okay, and then you'll do all that. Your solution is just this point here. Just whatever that intersection point is there. And hopefully you can tell what that is. I'm going to erase this, but it might be something like, maybe it's over 4 and then up 1, 2, 3, 4, 5, 4, 5. That's just an example, but you should be able to count and see particularly specific what it is. So I'll leave that. Okay, so next we'll look at something a little bit different, substitution. Level 1. Still dealing with systems, so still dealing with 2 equations. Y equals 8x and y equals 4x plus 8. Y equals 8x and y equals 4x plus 8. So what we're going to want to do with substitution, we're going to get a variable by itself. Get a variable by itself. So we only have, we have 4 variables total. We've got y, we've got x in the first equation, we've got y and x in the second equation. So 4 variables to choose from. A lot of times there's one that's easier than the others to get by itself. The reason this is level 1 is because they've already given you a variable that's by itself, the y in the top equation, all by itself. You could also use the y in the bottom equation that's already by itself. So what we're going to do is we're going to take what it's equal to. So let's say we knew, let's say we knew y was equal to 5. If we knew y, it's just hypothetically, if we knew y was equal to 5, then we could just change this y, insert a 5, and then we could solve for x. We'd move 8 to the other side, we'd divide by 4. But we don't know that y is equal to 5, so we can't do that. But we do have an equation that tells us y is equal to 8x. So what we're going to do is we're going to take what it's equal to and then plug it in the other equation for y. We know y is equal to 8x. So just like if it said y is equal to 5 and we replace y with 5, we're replacing y with the 8x instead. So this is going to be 8x now is equal to 4x plus 8. Okay, everybody follow that? Just substituting. So get a variable by itself, and then the second thing, substitute its value in the other equation. Y is equal to 8x, so we take the 8x, which is its value, and we substitute it in the other equation. Maybe I'll do this a different color. Okay, so substitute its value in the other equation. 8x equals 4x plus 8. You can solve that a few different ways. I'm going to get the x's on the same side, so that 4x on the right. This 4x on the right, I'm going to move over. So we'll subtract 4x on both sides. 4x is gone on the right. So we've got 8x minus 4x is 4x, 8 minus 4. And then equal to 8 on the right. Divide 4 so we can figure out what x is. Make sure you do that on both sides. We've got x equals 8 divided by 4, which is 2. Okay, and then a little note, don't forget to find y. Don't forget to find y, because really what we're looking for is, one equation might have a line, the other equation might have a line. We're looking for that intersection point. So that intersection point's an ordered pair, an x value and a y coordinate, x coordinate, y coordinate. So this part's usually pretty easy. So over here where I say, don't forget to find y, we already know y is equal to 8x, right? We have an equation that says y is equal to 8x. So y is going to be 16. So y is equal to 8 times 2 . So what that means is our solution, what's going to be the first number? 2. So always put the x first and then 16. Two and 16. The reason this is level 1 is because, the first thing we have to do is get a variable by itself. There's going to be some examples where you have to rearrange the equation in order to get one of the variables by itself. Here, they just give you y by itself. Okay, substitution. Level 2. Here we've got x equals negative 8y, and we've got negative x plus y equals 18. Substitution, we're going to get a variable by itself. And hopefully you notice I didn't say get y by itself, because sometimes you'll get x by itself. Sometimes that's the easiest of all the variables to get by itself. And on this one, we already have an x by itself. So just like the last instructions, we're going to substitute its value, whatever that x is equal to. We're going to substitute its value in the other equation. So if x was equal to 5, ignore that negative 8 part. If x was equal to 5, we put a 5 right here. So we have a minus and then 5. If it said x equals 5, it doesn't. It says x equals negative 8y. So we're going to replace this with a negative 8y, which should still have a minus in front of it. So minus in front of negative 8y plus y equals 18. So taking its value, plugging it in the other equation. So let's see, I'll do this in green. So now we've got negative 8y plus y equals 18. All I did was replace x in the second equation. The two minuses next to each other. So if we're going ahead with this a bit, the two minuses next to each other make positive. So now this is really 8y plus y equals 18. What number is in front of that y there? 1. So this is really 8y plus 1y, which we can combine, make 9y. 18, and then divide by 9. And we end up with y equals 18 divided by 9 is 2. Okay, and then hopefully don't forget, we are looking for an ordered pair. So you need an x coordinate and a y coordinate. We've got our y coordinate, so now we've got to find x. And again, this is hopefully the easy part. We do have an equation for x. X equals negative 8y. Y we know because we solved it, y is equal to 2. So it turns out x equals negative 8 times 2. Close. Negative 16. So when we put this in the answer, try not to forget this because there's a few different, kind of weaving around to get to the answer. What's the first number in there? Negative 16, and then the 2. Always x first and then y. Okay, we'll do one more of these and then I'll let you guys work. So this is substitution level 3. X minus 4y equals negative 8. And 5y minus 1 equals x. X minus 4y equals negative 8. 5y minus 1 equals x. Get a variable by itself. Again, that could be x or y. So you want to look at all the variables. Which one would be the easiest to get by itself? X on top or bottom? Bottom. Yeah, x on bottom is the easiest because it's already by itself. So we just have to take what it's equal to. We're saying this is what x is. We're saying x is equal to this. So in the other equation, are we going to replace x or y? X. We're saying x is this, so we're going to replace x. Just like if it said x is 5, you'd go into the top equation and put a 5 there where x is. Okay, so gonna write the top equation basically, but replacing the x. Maybe I'll write that here. X minus 4y equals negative 8. Instead of x, we've got 5y minus 1 minus 4y equals negative 8. Okay, just replacing x. Next, we've got some like terms. 5y and negative 4y, so 5 minus 4. Yeah, leaves you with 1y. And we do still have that minus 1. So putting the y's together, then we've got 1y minus 1 equals negative 8. So I'm just going to add 1. That'll get rid of the 1 part and it'll leave y by itself. So y is equal to negative 8 plus 1. That look good? Are we done? So I'm going to put a little, You might be tempted to put in -7 as your answer, but we still have to find x and then put it in an ordered pair. Well, since we're looking for x, we want an equation that says x equals something. So I may need to come around and explain this a little bit, but when you guys are working on it, but hopefully, we need to find x. You've got two equations at the start that we could look at, but only one of them tells us x is equal to this. And it's a little bit backwards, but you could say 5y minus 1 equals x. And then all you've got to do is plug in the -7 where the y is, and you'll have x equals whatever's on the left. So 5 times -7 minus 1 equals x. -35 minus 1 equals x. And so ultimately x equals -36. Okay, hopefully that's not too confusing for you guys. That's not all the notes. I'll finish the rest of the notes next Monday. But for anybody that's ahead of schedule and then wants to get started on module 3, you can. Lyman? What's that? You want me to go down or up? Go up. Okay. No, I'm sorry. Other way? Okay, I'll leave that up there.